Happy Monday, guys! Sorry I'm not with you today. I am in a meeting downstairs all day, but I wanted to make sure that you guys were able to get to the lesson we were going to get to on Friday, but the quiz took a little bit longer than we thought. So, today we are going to go through section 2.6, which is all about multiplying matrices. So please make sure you have out your notes packet and that you're opened up to 2.6. Now on Friday, remember we talked about what matrices are and how to add and subtract them. So today we're going to look at multiplying. We're going to start by doing this by hand, and then as you get better at that, you can use your graphing calculator to check your answers. Okay, here we go. So, in order to multiply matrices, we have to make sure that we're able to multiply the two matrices we're given together. When we looked at adding and subtracting, we had to make sure that they were the same dimensions. However, that's a little bit different from multiplying. In order to multiply two matrices together, they don't have to be the same size, but they do have to meet a certain set of requirements. When we look at the dimensions of each matrix, the number of columns in matrix A has to be equal to the number of rows in matrix B. So what I like to do is write out the dimensions for each matrix, and the inner dimensions have to be equal. Then, if we cross those out, the outer dimensions, meaning the rows in matrix A and the columns in matrix B, those will be the dimensions of your new matrix. Okay? So looking at example 1, it says, state whether the product AB is defined. If so, give the dimensions. So I'm going to start by rewriting the dimensions. Matrix A is a 4 by 3, and matrix B is a 3 by 2. So what I need to check is, are the columns from matrix A equal to the rows from matrix B? In this instance, yes, so we can multiply these two matrices together, and the resulting dimensions will be 4 by 2. In example B, I'm going to start by writing out my dimensions, 3 by 4, and 3 by 2. So I'm checking now, are the columns from matrix A equal to the rows from matrix B? No. So in this case, we could not multiply these two matrices together. Now we're going to look at how you actually do the multiplication. It's a little bit more complicated than adding and subtracting. We cannot simply multiply corresponding elements because the two matrices might not be the same size, which would mean we might not have an equal number of corresponding elements to multiply. So instead, we have to look at what the dimensions of our resulting matrix would be, and then, depending on the position of each element, that will tell us what rows and what columns we have to use to get the dimensions or get the elements for that position. So, if we are looking at row 1, column 1, that means that we are going to multiply that row from the first matrix by that column from the second matrix. Okay, so you can see here in this example, we have a 2 by 2 and a 2 by 2. Inner dimensions match. The resulting matrix will be a 2 by 2. So when I look at this position, this is row 1, column 1. So that means that we're going to multiply row 1 by column 1. So we're going to start with the first element times the first element, A times E. The second element times the second element, B times G, and add those two together to get just that first element. Okay, and then we would do the same thing for all the other elements in that matrix. So let's go ahead and look at an actual example. We're given matrix A and we're given matrix B. It says find A times B. So let's double check first of all to make sure we can actually multiply these matrices. So the first matrix is a 2 by 2. The second matrix is a 2 by 2. Our inner dimensions cancel out or are equal. So that means our resulting matrix will be a 2 by 2. So I like to start by actually drawing in the product, your final matrix. And we have 4 elements that will be in there. Okay, when I go to calculate these now, I'm going to use a matrix to help me keep all my work straight. So I'm going to start with this element here. Row 1, remember those are rows, these are columns, column 1. So that means I'm going to multiply row 1 times column 1. Okay, so first element 1 times first element 5 plus second element 4 times second element 9. We get 5 plus 36, which is 41. So our first element here is 41. Okay, proceeding horizontally now, our second position is row 1 still, but column 2. So I'm going to be multiplying row 1 this time by column 2. First element 1 times first element -7 plus second element 4 times second element 6. So I have -7 plus 24, which is 17. So our second element is 17. Okay, now moving on, we have row 2, column 1. So that means this time we are going to multiply row 2 by column 1. So first element 3 times first element 5 plus second element -2 times second element 9. So we have 15 plus -18, which is -3. All right, one element left. We have row 2, column 2. So I'm going to multiply row 2 by column 2. First element 3 times first element -7 plus second element -2 times second element 6. We'll have -21 plus -12, which is -33. So our last element here, -33. So this right here is our final answer. A 2 by 2 matrix, 4 elements, 41, 17, -3, -33. All right, let's try another example. So we have again a 2 by 2 times a 2 by 2. So I'm sure you can tell that right away our resulting matrix is going to be a 2 by 2. So I'm going to get that set up, ready to go. And I'm going to get my work set up, ready to go. So I'm going to start with first position, which is row 1, column 1, And you don't need to write all these things in as you're doing it. I'm just writing them in to help us stay organized as we're learning to do this. So we're multiplying row 1 times column 1. So first element, -3, times first element 1, plus second element 3 times second element -3. So we get -3 plus -9, which is -12. All right. Next element is in row 1, but column 2. So this time, we are multiplying row 1 by column 2. So we have -3 times 5 plus 3 times -2, which is -15 plus -6, which is -21. Okay? Next up, we have row 2, column 1. So we're multiplying row 2 by column 1. And we get 1 times 1 plus -2 times -3. So we have 1 plus +6, which is 7. And our last element is row 2, column 2. So I'm multiplying row 2 by column 2. So I have 1 times 5 plus -2 times -2, which is 5 plus 4, which is 9. So here we have our final product, a 2 by 2 matrix, 4 elements, -12, -21, 7, and 9. Okay, let's try another one. This time we have 2 operations happening, so we have to follow the order of operations, which says parentheses first. So the first thing I need to do is add matrix B plus matrix C. So first we have to determine, can we even do that? Now remember, with adding and subtracting, the requirement is that the matrices be the same size. So B is a 2 by 2, C is a 2 by 2. Yes, we can do that. So off to the side here, I'm going to write that B plus C. Now remember, for adding, we just add corresponding elements. So -3 plus 1 is -2. 0 plus 4 is 4. 1 plus -3 is -2. And -2 plus -1 is -3. So what we are being asked to do now is multiply this matrix times A. But we have to be careful because multiplying is not commutative when it comes to matrices. So since matrix A comes first, we are going to have to make sure that matrix A comes first in our multiplication, and then matrix B plus C is next. So let's check our dimensions. Matrix A is 3 rows, 1, 2, 3 rows, by 2 columns. B plus C is 2 rows by 2 columns. Do our inner dimensions match? Yes. 2 and 2 matches. So our resulting matrix will be a 3 by 2. So I'm going to go ahead and set up that resulting matrix, 3 rows by 2 columns. Okay? And I'm also going to set up the matrix that I'm going to do my work in. Okay? So let's go ahead and start. A 3 by 2. So I'm going to start with row 1, column 1. So that means I need to multiply row 1 by column 1. So we have 4 times -2 plus 3 times -2, which is -8 plus -6, which is -14. Okay? Now we need to go on to row 1, column 2. Row 1, column 2. So I'm multiplying row 1 this time by column 2. So 4 times 4, 3 times negative 3. I get 16 plus negative 9, which is 7. Okay? Next up, row 2, column 1. So I'm multiplying row 2 by column 1. So negative 1 times negative 2 plus negative 2 times negative 2. So I get positive 2 plus positive 4, which is not 8, it is 6. Okay? Next element is row 2, column 2. So I'm multiplying row 2 by column 2. And I have negative 1 times 4 plus negative 2 times negative 3. So I have negative 4 plus 6, which is 2. Okay? All right, one row left. So element is row 3, column 1. So I'll be multiplying row 3 by column 1. And I'll get 2 times negative 2 plus 0, love that 0, times negative 2. So I get negative 4 plus 0, which is negative 4. And our very last element is located in row 3, column 2. So I'll be multiplying row 3 by column 2. So positive 2 times positive 4 plus 0 times negative 3. And we'll get 8 plus 0, which is 8. So there you have it. Your resulting matrix is a 3 by 2. Okay? All right. This chart right here talks about the properties of multiplication. Don't worry too much about this. The most important thing that you remember is that it's not commutative, which is what we talked about before. If it says matrix A times matrix B, you have to make sure that matrix A is in the first position and that matrix B is in the second position. We cannot flip-flop them, just like we couldn't for subtraction, because it will change the resulting matrices. All right, let's try one more example. This one says A times matrix B minus C. So we need to start with the order of operations located inside the parentheses. We have B minus C. Can we do it? Yes, B is a 2 by 2, C is a 2 by 2, so we can subtract them, B minus C. So 3 minus negative 4 is actually turning that to 3 plus 4, which is 7. 2 minus 5 is negative 3. Negative 2 minus 1 is negative 3. And negative 1 minus 0 is negative 1. So now we need to multiply matrix A by this new matrix. So let's check our dimensions. Matrix A is a 3-row by 2 column. B minus C is a 2-row by 2 column. So our inner dimensions are the same. So our resulting dimensions will again be a 3 by 2. So I'm going to go ahead and set that up. A 3 by 2 matrix. And I'm going to set up my matrix for my work. I'm going to go a little bit faster through this one. Feel free to pause me if I'm going too quickly. So, first position is row 1, column 1. So I need to multiply row 1 by column 1. So I'll have negative 1 times 7 plus 2 times negative 3. So negative 7 plus negative 6, which is negative 13. Second position, row 1, column 2. So I'll be multiplying row 1 by column 2. So I'll have negative 1 times negative 3 plus 2 times negative 1. So that's positive 3 plus negative 2, which is 1. Next position is row 2, column 1. So row 2 times column 1. Negative 3 times 7 plus 0 times negative 3. So negative 21 plus 0 is negative 21. Next position is row 2, column 2. Row 2 times column 2. So we get negative 3 times negative 3 plus 0 times negative 1, which is positive 9 plus 0, which is positive 9. Last row, the first position is row 3, column 1. So row 3 times column 1, we get 4 times 7 plus 1 times negative 3. So we get 28 plus negative 3, which is 25. And our last element is located in row 3, column 2. So I'm multiplying row 3 by column 2. So 4 times negative 3 plus 1 times negative 1, which is negative 12, plus negative 1, which is negative 13. Okay? So again, we had another 3 by 2 matrix multiplication. All right. I'm not going to go through this example, but I'm just going to talk about what you would quickly do is you would multiply matrix A times matrix B because that's what's in parentheses. And then you would multiply that entire matrix by the scalar negative 1/2. Okay? Now, your assignment for today is the worksheet practice 2.6. There are 8 matrix multiplications on there. It will be due tomorrow for first hour and Wednesday for hours 5, 6, and 8. You may use your graphing calculator to do these. So that would mean going in and inputting matrix A and matrix B, and then doing matrix A times matrix B. But I would strongly recommend that you try to do some of these by hand because on your test there will be a no calculator section and you will be required to do addition, subtraction, scalar multiplication, and matrix times matrix multiplication by hand. So make sure you practice at least a couple of these. Tomorrow, you will also be getting your quizzes back from Friday. If you haven't taken it yet, or you haven't finished it, please make sure you stop by and see me after school today. Okay? Have a great day, guys!